Dear students, in the past lecture, in the previous lecture, we closed up with the closed cycle gas turbine, gas-based power plant, and for the closed cycle, we said that the hot gas that comes out of the turbine is cooled in a heat exchanger, and the cold gas is again fed. Okay, or cold gas or cold air is again fed to the compressor, and it is compressed and then fed into the combustion chamber where the fuel is burned and expanded, and more energetic gas is to drives the turbine. Here, to cool the gas or the air that is coming out of the turbine, water is used. Okay, so water takes away the heat from the hot gases, and as we can see over here that or we have studied earlier that the temperature is very high, 1200 degrees Celsius around, right? So what will it do? It will vaporize the water. That means it will turn the water into vapor. So instead of, I've written earlier that it was water out, but it should not be water out, it should be steam that comes out of this heat exchanger. Okay, now we can utilize this steam to generate uh, electricity by running the turbine through this steam. Okay, so that's what we are going to study in the combined cycle power plant. By combined cycle, we mean that we are combining two cycles. First of all, this cycle, which is based on Brayton cycle of thermodynamics, and second one is the steam based cycle that is also known as the Rankine cycle that you must have studied in your first unit. So in order to utilize the heat expelled from the turbine of the gas power plant, which still has a lot of energy, a steam based power plant is employed. So gas based power plant becomes the topping cycle, or we can say that this occurs first. This cycle occurs first, the gas based, so it is known as the topping cycle, and the steam cycle or the Rankine cycle occurs next to it or after that, so that it becomes the bottoming cycle. These two cycles are simultaneously used to increase the efficiency of the overall plant. You will appreciate this point by this, that the overall efficiency basically is given as efficiency of the gas based power plant plus efficiency of the steam based power plant minus product of the efficiency of both the power plants. So for example, we have seen that the efficiency of the thermal power plant and the gas based power plant are approximately similar. So let us take around about 40% of both the efficiencies. So if it is 40% efficiency, we can say 0.4. The efficiency of the gas based power plant is 0.4 plus 0.4, or the 40% is the efficiency of the steam based power plant minus the product of this. If we calculate this, I'm using calculator right now. It should be it should be 0.8, right? 0.8 minus 0.16, approximately, that means 64%. So earlier the efficiency of the gas based turbine was 40% only. We have increased to 64%. So the overall efficiency of the power or the energy that is being extracted from the heat that has been developed has increased, right? Now the concept is bit like this. You have to write it in your own words. Okay, we are having a combustion chamber. Okay, or we can say this green part is the gas based power plant, and this is the steam cycle, okay, or steam based power plant, in which we are having a compressor. where the air is compressed. It is fed to the combustion chamber where the fuel is burned, and the air is then at that pressure, the temperature and the volume of that gas increases, and then it runs the turbine. The turbine and the expelled gas cools down in the heat exchanger that we recently saw. The heat that is developed, that has been extracted from the heat exchanger by the water, it turns into the turbine. Now this B is the boiler. Okay, this boiler is similar to what? This boiler is, or the heat exchanger are same thing. Okay, and the steam generated in the boiler turns the turbine, or it rotates the turbine. After rotating, the expelled steam goes to the condenser. In steam power plant, we have condenser that cools down the steam. This steam then converts, then it is pumped back to the boiler. The water is then pumped back to the boiler. So this structure is more clear in this fashion. We have a compressor that compresses the air. This is a combustion chamber. Then we have the gas turbine. We have two turbines, the gas turbine and the steam turbine. This gas turbine is then the air is expelled and the heat is exchanged over air. It transforms from the gas to the water, which turns it back to the steam, right? This water is then fed to the steam turbine. The steam turbine runs and generates electricity. This expelled steam is again, it goes to the condenser where it is turned back to water. This water is pumped back to the boiler, right? This is the another cycle. This cycle is denoted by this. Okay. Now coming to their TS curve, or the temperature entropy curve. This cycle is already what we have seen. After going out of this cycle, we go to the Rankine cycle, which is the cycle for this one. Okay, so in the boiler there is no mechanical work done, and the entropy of the water or the steam increases. We are using a superheater. We always use a superheater. You must have studied in that. What we do is we again increase the temperature and the entropy of this steam by using the pipelines back into this heat exchanger or the boiler. Then this rotates the turbine, in which the temperature falls down, the entropy remains the same, and the mechanical work is being done. Of course, there must be a slight change. It should not be exactly a straight line. It should be a drooping line, because some mechanical work is being done. Okay, or some work is or some losses are there in the turbine also. This line denotes that there are no losses in the turbine. And here we are having the condenser, in which the entropy drops in the condenser and the state changes from the steam to water. Then the pump utilizes certain energy in pumping back to the boiler. Before going to the boiler, what we do is we heat back because the water over here in this boiler is very hot. Okay, we don't directly feed the cold water to the boiler or the heat exchanger. In this case, what we do is we reheat, or we use an economizer, or it is again certain pipelines that are used to increase this temperature of this water, so that when it reaches this point, it reaches the boiler, it is already up till this temperature. Because if this is not so, cold water will reach the hot water zone, and it will there will be a drastic temperature difference, and this will lead to the burst of this boiler or the heat exchanger. So we increase the entropy and temperature of this water by passing it through the economizer. So this cycle is the Rankine cycle that occurs. So these two cycles, because this is coming at the top, because it is at higher temperature, at higher entropy, at higher pressure, okay, so that this cycle, because it is occurring first and it is in the at the top of the Rankine cycle in the temperature and entropy curve, this is known as the topping cycle, and this cycle is coming below the topping cycle, that's why it is known as the bottoming cycle. I hope now you have understood the concept of the topping cycle and bottoming cycle, or the combination of two cycles in order to generate the electricity in two zones. Okay, electricity is being generated in the with the help of gas turbine and the steam turbine. Okay, now we can use different types of fuels in this combustion chamber. Okay, what if we use coal as our fuel? There are two methods that are commonly used. One is known as a pressurized fluidized bed combustion system. Another is known as the integrated gasification combined cycle. And in this, I will discuss in the next video. Thank you.